This class we discuss about different type of lighting system and the flux or lumen method of calculations. Already we discussed 6 types of lighting systems. One is a direct lighting system. In this system, 90 to 10% of light is downward, 0 to 10% is upward. Where in the case of indirect lighting, 0 to 10% is downward, 90 to 100% is upward. Semi-direct, in semi-direct, 60 to 90% is downward, 10 to 40% is upward. Semi-indirect, in this case, 10 to 40% is downward, 60 to 90% is upward. Another is general diffuse. Here, 50% is downward and 50% is upward. And mixed diffuse, in the case, here this is a black surface, therefore 40 to 60% is downward, 40 to 60% is upward. In illumination engineering, 2 terms are commonly used. One is lamp efficacy and lamp efficiency. In previous problems, I wrongly mentioned lamp efficiency in lumen per watt. That is wrong. That is lamp efficacy. Lamp efficacy is equal to lumen per watt. For example, it's a 100 watts bulb. Its lamp efficacy is equal to 40 lumen per watt or 50 lumen per watt. Where in the case of lamp efficiency, all electrical energy applied to a lamp is not converted into luminous flux. Some energy is wasted in creation of heat and sound also. The ratio of luminous energy to total applied energy is called luminous efficiency of lamp. In lumen or flux method of calculations, there are 9 steps are involved. This method is widely used in interior lighting design. We know that average illumination E is equal to flux required on working plane divided by area of working plane. Average illumination E is equal to flux output of each lamp into number of lamps into utilization factor into depreciation factor divided by area. The steps are: number 1, select a type of lamp and fitting. Number 2, mounting height above the working plane. Number 3, layout of the lighting points is obtained using suitable spacing to height ratio for the fitting. Number 4, choose a suitable value of illumination or lux. Number 5, select maintenance factor. 0.6 for dirty situation and 0.8 for clean situation. Number 6, calculate room index. Room index is equal to, for a rectangular area, the length into width, that is the room length into width divided by room length plus width into HM, that is mounting height, that is a room index. Calculate the room index and determine the utilization factor from the handbook. It is a rectangular area, this is the formula. For a various size, different, we have to use the room index. According to that, we have to choose that value from the engineer's handbook. Number 7, select the wattage of lamp. Number 8, select a suitable fitting. Number 9, calculate the effective spacing height ratio. Space height ratio is equal to root of area AT, that is the total area into N, number of lamps, divided by HM, mounting height. Problem 1. A drawing hall 30 meter by 15 meter with a ceiling height of 5 meter is to be provided with an illumination of 120 lux. Taking the coefficient of utilization as 0.5 and the depreciation factor as 1.4. Determine the number of fluorescent tubes required, their mounting height, spacing and disposition. The 80 watt fluorescent tube, its lamp efficacy is 40 lumens per watt. In this problem, size of the room is given 30 by 15. Ceiling height is given 5 meters and illumination is given 120 lux, that is required. Utilization factor is equal to 0.5, depreciation factor is equal to 1.4. Determine the number of fluorescent tubes, mounting height, spacing and disposition. Here the depreciation value is 1.4. Since it is 1.4, df is equal to 1 by 1.4 is equal to 0.71. The total lumens required is equal to area into E divided by utilization factor into depreciation factor. Substitute all the values. We will get 1,52,112.68 lumens. And lamp efficacy is given 40 lumens per watt. So therefore, this lumen, the total lumens divided by lamp efficacy 40, that is 3802.82 watts. How many lamps we require? That is 80 watt lamp. That is 3802.82 divided by 80 is equal to 47.53. We need 48 lamps. We go for number of fittings. Each fitting contains two 80 watt lamps. Therefore, number of fittings is equal to 48 divided by 2 is equal to 24. So, each fitting contains two tube lights. Here 3 rows, 8 columns. Therefore 3 into 8 is equal to 24. 24 lamps we required. And that is 24 fittings. Total number of lamps is 48. Here we have to find the horizontal distance as well as the vertical distance. Horizontal distance is nothing but this is 30. 30 divided by 8 columns, that is 30 divided by 9 is equal to 3.33. The vertical side, this is 15. 15 divided by 4 is equal to 3.75. Space height ratio is equal to horizontal distance divided by mounting height. If you choose mounting height 3, 3.33 by 3 is equal to 1.11, which is within the limit. That is 1 to 1.5 should be the space height ratio. This is 1.11. So mounting height is 3. Spacing is 3.33 in horizontal, in vertical side 3.75. This is a 24 tube fittings. Each fitting contains 2 tube lights. A drawing hall 36 meters by 20 meters is to be illuminated so as to get an illumination of 33.8 lumens per meter square on a working plane. Luminous efficiency is equal to 15 lumens per watt. Mounting height is equal to 3 meters. Space height ratio is equal to 1.3. Utilization factor is equal to 0.5. Depreciation factor is equal to 0.75. Calculate the number of lamp, wattage of each lamp and their disposition. In this problem, drawing hall size is given 36 by 20. Illumination required is given 33.8 lumens per meter square. Lamp efficacy is given 50 lumens per watt. Depreciation factor is equal to 0.75. Utilization factor is equal to 0.5. Space height ratio is equal to 1.3. Mounting height is equal to 3. Illumination required is equal to area into E divided by utilization factor into depreciation factor. We know all the values. Just to substitute the value, we will get 64,896 lumen illumination, that is the lumens required. Total wattage is equal to illumination required divided by lamp efficacy. So 64,896 divided by lamp efficacy is given 15 lumens per watt divided by 15 is equal to 4,326 watts. Space height ratio is equal to horizontal distance between lamps divided by mounting height. Mounting height is given 3. Therefore, horizontal distance between the lamps is equal to 1.3 into 3, that is equal to 3.9, that almost equal to 4. Therefore, here the length is 36 and width is 20. 36 by 4 is equal to 9 lamps. And 20 by 4 is equal to 5 lamps. Length-wise 9 lamps, width-wise 5 lamps. Therefore, total number of lamps is equal to 9 into 5, 45. We have to find the wattage of the lamp. We know the total wattage is 4,326 and number of lamp is 45. Therefore, wattage of each lamp is equal to 4,326 divided by 45, that is equal to 96.13, almost 100 watts. So, we are using 100 watts and 45 lamps. We have to draw the spacing layout and we know the horizontal distance between the two lamps is 4. Here there are 9 lamps, 8 columns inside. Here 8 into 4 is equal to 32. This side is 2 and this side is 2. 32 plus 4 is equal to 36. Similarly, here we are using 5 lamps. The distance is 4 into 4, 16 plus 2 plus 2, that is equal to 20. So the wattage of the lamp is equal to 10. Number of lamp is equal to 45. This is the spacing layout. Problem 3. A reception hall 30 meter long and 20 meter wide is to be illuminated, and the illumination required is 50 meter candles. Assume depreciation factor is equal to 1.4, utilization factor is equal to 0.5, mounting height is equal to 5. 5 types of lamps having lumens output as given below. 100 watts 1615 lumens, 200 watts 3650 lumens, 300 watts 4700 lumens, 500 watts 9950 lumens. Calculate the number of lamps needed and also draw the spacing layout. So in this problem, reception hall size is given 30 meter by 20 meter. Illumination is given 50 meter candles. Depreciation factor is equal to 1.4. Utilization factor is equal to 0.5. Mounting height is equal to 5 meters. 4 type of lamp, that is 100 watt. Its lumens output is 1650 lumens. 200 watt. Its lumen output is 3650 lumens. And this is 300 watt. Lumen output is 4700 lumens. This is 500 watt. Output lumen is 9950 lumens. So I can easily find how many number of lamp required. Illumination required is equal to A into E divided by utilization factor into depreciation factor. Here the depreciation factor value is 1.4. Since it is 1.4, 1 by 1.4 is equal to 0.71. Substitute all the values. I will get illumination required is equal to 63,380 lumens. Now I can easily find how many number of lamps I require. So 100 watts I need 40 lamps. 200 watts 18 lamps. 300 watts 14 lamps. 500 watts I need 7. That is simple. Total lumens required divided by lumens output of a 5 lamps, that is 100 is 1650, that is equal to 39.24. I choose 40 lamps. Now I have to draw a spacing layout and I also find the wattage of the lamp. I choose 200 watt lamp. Here in the 200 watt lamp I have to fix 18 lamps. Number of lamp is 18. Here the lengthwise I can fix 6 lamps. That is lengthwise 6 lamps and widthwise 3 lamps. So 6 into 3 is equal to 18 lamps. 18 into its lumen output is 3650, that is equal to 65,700, which is higher than the calculated value, that is 63,380 lumens. Therefore I choose 200 watts. This is the spacing layout. This is 2.5, this is 2.5, 1, 2, 3, 4, 5, 6. 25 plus 2.5 plus 2.5 is equal to 30. Here 20 by 4, this is 5, 5, 5, 5. Horizontal distance between the two lamps is 5. Divided by mounting height is given 5. Space height ratio is equal to 1. This is the spacing layout. Wattage of the lamp is 200 watt. Space height ratio is equal to 1. With this I conclude my lecture. Thanks for listening my lecture.